Okay, so first I have to apologize because I'm doing this in the hospital, so there might be some noise in the background, but let's just deal with it and get through this. I'm going to go through it kind of quick, so you can pause it if you need to stop and hear what I said again. So just looking at what we looked at the other day, so a proper graph has an x and y axis and an appropriate scale. We need to make sure our scale fits our graph. Then we looked at the different quadrants, so we've got quadrant 1, 2, 3, and 4. Whoop. And then our x-axis is always the horizontal, which is why I'm putting the y up here where it already says y. And x is down here, or on the other side you can see it. And remember, the origin is in the middle, so 0, 0. This is all part of the Cartesian plane. I would never really ask you to define what the Cartesian plane is, but you should know all of these things. Then we've labeled points. We always labeled x and then y, so 7, 2, -2, 7, -7, -2, and 2, -7. Okay, always x then y. And that's what I've just said here, so that would be x, y. So whenever you're looking at ordered pairs, always, whoa, that's big font, x and y. And then we use the hotel analogy. Okay, so looking at this, we've got a Cartesian plane here, and we want to know what those points are. So your x for this one, so we would have D being 7 and then 3. So D is 7, 3, x, and then y. Let's actually do this in order. So A, -4, 6. -4, 6, x, y. B is 2, -3. To the right 2, down 3. C is -6, -4. And D we've already done is 7, 3. Now looking at this, we can see that D is in quadrant 1, A is in quadrant 2, C is in quadrant 3, B is in quadrant 4. What can you tell, or what does the x-coordinate tell you about the point? It tells you whether it goes right or left. So positive to the right, negative to the left. Y, up or down, positive up, negative down. What are the coordinates of the origin? 0, 0, because we don't move. We don't go left, we don't go right, we don't go up, we don't go down. Okay, so plotting the following points. 5, 0, so go over to the 5, go up 0, 0, 6, -7, 0, and 0, -8. And remember, these are all on the axis, so they're not in any quadrant. They're on the x-axis or the y-axis. Now looking at this, we talked about this graph. It's a positive linear graph. It's got a strong correlation, and then we have this little guy over here, and he's called an outlier, but we're not going to worry about that right now. I'm actually going to explain it further on in the note. Success criteria for drawing a graph. Make sure you use a ruler to draw your axis. Make sure you label your axis, add a scale to the axis, and extend it the full length. When we're looking at variables, we've got an independent and dependent variable. So when you're looking at a variable, the independent variable is always the cause. Okay, so that's always on the horizontal axis. It's like time or things like that. Time is always an independent variable because no matter what we do, time doesn't change. Okay, time always goes at a constant rate. It's never going to change. That's dependent or independent. Dependent means it changes based on something. So it's the effect, the cause, and the effect. Okay? When you're looking at independent, it's normally the first column or the top column. So independent, independent, independent. Okay? So it would be the independent here. Independent. And this would be the dependent. 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 Okay, and that's what we're looking at there. Okay, now a scatter plot shows the relationship between things, so like attendance and achievement. So if you don't miss class, because going here you'd be missing more class, your achievement's better. Now there's an outlier here with somebody that's missed a lot of class and still has high achievement. Okay, so a graph shows a relationship between two variables. We're saying here that the more class you miss, the lower your achievement. The points aren't connected. We actually just have a line of best fit. Okay, a line of best fit shows the trend of the data, and we never include outliers when we're putting that line of best fit in. So an outlier is a point on a scatter plot that does not seem to follow the trend, so it's an unusual value. Relationships and correlations. So is there a relationship between the dependent and independent variables? Does the value of y depend on x? So a linear relationship, I'm going to just change this back to a pen, would look something like this, where we've got a bunch of points and they're all kind of following a line. A nonlinear relationship, now there's tons of different nonlinear relationships, but if I look at this is nonlinear. This is actually exponential, so you hear about exponential growth all the time. That's an exponential relationship. Now no correlation would be something like this. Just looks like a bunch of random dots. Positive relationships. Positive relationships go up to the right. Negative relationships go down to the right. Okay, so an example of a positive relationship is the more hours you study, the higher your mark would go up. A negative relationship is what we just looked at. The more classes you missed, the lower your mark will be. Okay, now remember there's always outliers, and these are just general trends or relationships that we follow. Strength of relationships. I'm going to have to change my little markings here. I can't have huge dots anymore. But a strong relationship or strong correlation, it follows a pattern and all the dots are relatively close together. Okay, and they would all be fairly close to our line of best fit. So if I drew a line there, all fairly close. Okay, a weak relationship might look like this, where you can still kind of see that there's a clear trend there. Okay, but the dots are not as tightly bunched. Okay, so typically I'd be writing like tightly bunched to the line, all follow the same trend. Now here they're not as tightly following that line, but they're still following a trend. And again, no correlation, we've already talked about this. Would just kind of be dots everywhere. And I can't really draw a line of best fit because there's no correlation between the two pieces of data. Alright. Now, a non-linear relationship can both be positive and negative, or both. So remember, positive is up to the right. Here's a non-linear relationship up to the right. Okay, it's going up that way. A linear or non-linear relationship that goes down to the right. Okay, something like that. And the dots would follow this pattern. Or both. It's going up to the right until right there. And it goes down to the right after. This is actually a bell curve. If you take statistics later, that's a huge thing that you'll see over and over and over and over again. You'll actually see it in grade 12 if you take chemistry. Your fourth year IB chemistry, you do a lot of that as well. Now a flow chart to kind of follow. Look at the relationship. First, is it linear, non-linear, or is there no correlation? Second, is it positive or negative? Okay, now non-linear, remember it could be both. And then look at how strong or weak it is. Typically we're only going to look at these two with linear relationships because it's hard to distinguish with non-linear. All right, so kind of looking at some examples here. This, I would say, is a linear relationship with a fairly strong positive correlation. Here, linear relationship, fairly strong negative correlation. You can hear some garbage being pulled down the hallway now. This, I would say, is a no correlation. This we could call linear weak relationship, but it's negative. This might be a non-linear positive relationship, and I would say it's a weak. It's not really following a trend. And finally, a strong non-linear relationship. And we'll end on that. There's some homework for the note. I hope you guys can hear this okay.